Hello, YouTube. This is Uno03. So now we're on to lesson 40 in the Java curriculum. And in the previous lesson, we introduced the topic of sorting algorithms. And we said that basically we can come up with different ways, different procedures for completing standard tasks in a programming language, for example, Java. And so one of the examples that the introductory computer programming courses give is sorting an array. So if you have an array of ints or doubles, or more generally, something with a property that's sortable, something that can be sorted. For example, if you're talking about an array of strings and those strings have different lengths, then you could call the length property and you could sort strings according to their lengths. So for any element that has a sortable property to it, we can come up with different methods for sorting the elements in the list. And in the previous video, we introduced one sorting algorithm called bubble sort. And so what we did is we were looking at our class architecture here, and most of these classes, 9 of these classes, were ones that we spent a great deal of time talking about when we were doing the object-oriented unit. But then in the most recent lesson, we went ahead and created a sorting class, and we said that we're going to be using this class for this lesson, the previous lesson, and then we're going to use it one more time in the next lesson. And what we had here was essentially we had a main method, which was just going to create 4 one-dimensional arrays of ints. And then we went ahead and formed a 2-dimensional array of ints just by passing in those one-dimensional array of ints. And then we went ahead and called the sort and print arrays method on the 2-dimensional array. And so what does the sort and print arrays method do? Well, it doesn't return anything. It just prints code, right? It's a void method, but it accepts a 2-dimensional array of ints. And so what it does is it's going to bubble sort each of those one-dimensional arrays in the 2-dimensional array. And then for each of those one-dimensional arrays, it's going to iterate through each of the elements in those one-dimensional arrays and print them. So hopefully we'll see a sorted result. So then if we go ahead and call the bubble sort method, remember we went ahead and compiled, and then we went ahead and ran the main method, and then we see the console output. So we went ahead and had those 4 arrays, and then indeed all the numbers are aligned from smallest to largest. And then if you wanted to go ahead and align them from largest to smallest, what kind of adjustment would you make? So what you would do is you would simply reverse this Boolean. So you could say, okay, I only want to flip the values if the current value is smaller than the next value, which means that you'd actually have a descending array. So now if you go ahead and run the main method, literally just by turning in one sign into the opposite sign, look, you get basically the opposite code. And so that's bubble sort. So we were taking a look at the bubble sort architecture here, and this is what we have going on here. So our example, we did it with an array of ints. But for this sorting algorithm, we're going to be talking about insertion sort in this video, and we're going to do it on strings, or an array of strings, because we said that the length is an int that can, those ints can be sorted, the lengths. And then in the next video, when we talk about selection sort, we're going to do it on person objects. Because if you recall from a few lessons ago, basically what we did is we said that the person class is going to implement the comparable interface. And we says that by implementing the comparable interface, we are required to create a method that returns an int called compareTo, which accepts an object and defines what it means to compare 2 objects of the same type. So we would be explicitly casting the object to a person. This object that we're passing in is cast to a person. And then we can just look at the getName method, the length method on this string object. So the length method called on the string object returned by the getName method, which if you scroll down, we see that the getName method just returns the name. So it would look at the other person's name and this person's name, the current person's name. And so the whole point is that person objects can be sorted too. So we could sort an array of person objects according to the lengths of people's names. And so we're going to go ahead and do that in the next video. But for this video, we're going to be demonstrating insertion sort with an array of string objects. And the only thing that's going to be different, what's going to be sortable about string objects, is their lengths. So let's go ahead and look again one more time at the bubble sort algorithm. Remember, with bubble sort, we have basically a nested loop. We have nested for loops. And so you're going to iterate through each of the elements in the array. That's basically what this while loop does. And then for each of those elements, you need to compare it with all the other elements remaining in the array, like starting at that position and looking at all the other elements. And you're sort of going to build it from the ground up, because the smaller values are going to be bubbled to the beginning. Let's just switch it back to ascending. So the smaller values are going to basically come towards the beginning of the list, because right now the current value is larger than the next value, and so we go ahead and swap it so that the next value will be larger than the current value. So this gives us an ascending bubble sort. So hopefully that's clear to you, and then we're just going to return the array at the end. So what does this method do? What does it accept and what does it return? The parameter is an int array. The return is an int array. The difference between them is the manual work of doing these comparisons and looking at this Boolean over and over again in the context of a nested for loop and being able to switch elements if they're out of order. What we're going to do now is we're going to take a look at the insertion sort algorithm. And right now I basically just have a template for the insertion sort method. And so we're going to have to fill this out. And we're going to do two insertion sort algorithms. We're going to do one with an int array, and then we're going to have a very similar one for a string array. So with an int array, all we can do is just say, oh, array of j is array of j plus 1, right? We can just look at one number and see whether it's smaller or larger than another element in the array. With string arrays, it's going to be very simple, except instead of just saying, oh, is one string bigger than another string object in the array, we're going to have to just call the length method. So is the length method applied to this string object larger than the length method applied to another string object? So we're going to be sorting, not ints this time. I mean, we can demonstrate the insertion sort with the ints, just like we did for bubble sort, but I want to take it one step further and try to compare something that's just more generally sortable. So a string array, or a person array. We're going to be doing that in this video and the next. So in order to understand the insertion sort, let's start with documentation. So I already have some documentation here, and you can see it's very, very similar to the documentation that we wrote in the previous lesson for the bubble sort method. So this one, it's really identical, except it says according to the insertion sort algorithm rather than according to the bubble sort algorithm, but the parameter in the return is the same. We're still going to pass in an unsorted int array, and we're still going to return a sorted int array. So the param and return aren't different so much as just the description, just this one word here. Fundamentally, what algorithm, what approach, what method is Java taking to sort the numbers? And you can think about a couple of different ways that you could sort numbers in an array, right? Are you going to just bubble them one at a time, or are you going to look for the largest one each time and just put it at the end? So you can think, or are you going to break up the array into smaller arrays over and over again? So you can think about how there could be maybe more than one slightly different way for a computer to sort an array, to sort an array of elements, right? And so instead of just returning the same array that we get, right, because this would be basically an ineffective method, and if you submitted this on an exam, your code would compile, but it wouldn't do what you wanted to do, right? If we go ahead and just return the same array that we have, and then we come up here in the sort and print arrays method and we modify this bubble sort to instead call the insertion sort method, and then we go ahead and compile it and run it, right, then this result is going to be wrong, right? So this is just the numbers that we started with. This is how we entered the arrays, and so no work has been done yet. So the question is, what is the mechanism of the insertion sort? And now I'm going to tell you. So what we're going to do, I actually just am going to copy and paste some code real quick. I actually have some code on my clipboard, but we're going to talk about what it's doing, and then we're going to replicate very similar code for the string arrays and test it on an array of string objects. So what we're going to do is we're going to take a look at creating a variable called n. And you don't have to do this step, but it would just save you a little bit. It would save you, basically, it would make your for loop a little bit more compact, right? So if you don't want to create a variable called n, it looks like it's only used in one space. So if you don't want to say in n equals array.length, you probably could have just said for in I equals 1, I is less than array.length, because n is array.length. So you can go ahead and take that out if you want, it's up to you. But the name of the array coming in is parameterized as array, so you need to keep that consistent throughout the definition of the method. If you called it x up here, instead of saying I is less than x.length as the instead of saying I is less than array.length as the Boolean, you would say I is less than x.length as the Boolean. And then it just creates another variable. So this is just sort of for ease of reading, right? I mean, you don't have to really create a variable here. Instead of saying array of j is larger than key, you could have just said array of j is larger than array of I, right? And then down here, you could have just said array of j plus 1 is array of I. But it's just creating a variable, and maybe, it's up to you. It's sort of a matter of personal preference, but do you think that that makes the code more readable or not? Same thing happens with j. So j is just declared to be I minus 1, at least here in the beginning, but then it looks like it's going to update its value in the while loop. So anyway, here's how the insertion sort method works. What you want to do, what you want to think about conceptually is that when people manually sort cards in a hand of bridge, if you're playing a card game with friends or something, most people would use a method that's similar to insertion sort in order to sort that hand. So essentially the way the algorithm works is that it iterates, and it basically consumes one input at each repetition, and it grows a sorted output list. So your sorted list is growing to be larger and larger, and your unsorted collection, you're going to be removing elements from that as the method progresses. Okay, so what you're going to do is you're going to say int key equals array of I. So we're just going to iterate. We're just going to iterate. This is just a for loop. We know how to do this. So it's just going to iterate for each of the values of I, starting at 1 and then stopping just before the length of the array, right? So for example, if you're talking about an array of length 10, then I could be all the way up to 9, right? But then once I gets to 10, 10 is not less than 10. So I equals 9 is the last, value of I that the method would run with if the length of the array is 10. So it's just going to say I equals 1, and then maybe you could say I, less than 10, for example, whatever the length of the array is, and then I plus plus. And then you're just going to make the key equal to the elements at that index position. So whatever it is, are you talking about the first element, the third element, the seventh element, but key is going to be that element. And J is going to be one element, one index position to the left of that. So you're going to be looking at one index position to the left of that to start. And you're going to say if that element that's, if the element that's one index position to the left is larger than the element that I'm currently looking at, then I'm going to go ahead and make that switch. So I would just say array of J plus 1 is equal to array of J. And so this would be moving the bigger elements, which is array of J, into the array of J plus 1 position. So that's the swap. And it's sort of parallel to what we do here, right? In the bubble sort, we check for a Boolean, and we say if these numbers are out of order, you need to swap them. And that's essentially sort of what's happening here. And then after that while loop terminates, after either J becomes less than 0 or array of J becomes less than or equal to key, once one of those Booleans fails, remember this is an AND. So if this is false or this is false, we're done with the loop, and we immediately drop down here, and we're going to say array of J plus 1 is key, and key was just array of I. So the key was the element at that particular index position for this iteration of the for loop, for this value of I. And then so you're just going to do that a number of times, and then you're just going to go ahead and return the array. And so that's what it would look like for an int array, and we can go ahead and demonstrate that. So now that this is filled in, now that this is a complete implementation, what we're going to do is we're going to try running the insertion sort method again. So the main method is absolutely identical to the main method that we had in the bubble sort algorithm. It still calls the same method, sort and print arrays. The difference is what sort and print arrays does. Is it going to call our bubble sort method, or is it going to call our insertion sort method? Well, the last time we ran the insertion sort method, it wasn't doing much sorting because we just returned to the same array as we were given. But now we're going to make these swaps and adjustments according to the Boolean that checks to see if the previous element, the one to the left, is larger than the element that we're dealing with. And if it is, we need to switch that. We need to go ahead and make that replacement. So now if we go ahead and run the main method, now our numbers are sorted again, and it's running the insertion sort algorithm, which is different from the previous video, because in the previous video we were running the bubble sort algorithm. But the reason why we study the insertion sort algorithm is because it's more efficient than bubble sort. So the code is just a little bit harder for the programmer to understand. It's just a little bit more confusing what's going on here, but it ends up resulting in a little bit less work for the program. If you're talking about an array of 4 or 5 elements, you could run a bubble sort on it, right? You could do that on your head. You could do that with pen and paper, right? And you could do the algorithm. You could take a look at the elements and just bubble up the larger ones to the end of the list. And if you're talking about a list of 5 or 6 elements, that's really not that big of a deal, right? 5, an inefficient method, but it's only running on 5 lists, right? It's a pretty hard to mess up an operation on a list with 5 elements. But if you're talking about large data structures, you're talking about an array list, right, where you've added 500 person objects and you want to have all of them sorted as quickly as possible, and you don't want the computer to just overturn doing more work than it needs to do, then you would be smart, it would be prudent to go ahead and call the insertion sort algorithm rather than the bubble sort algorithm, because the insertion sort algorithm is more efficient for the computer than the bubble sort algorithm. So that's essentially how that works. And then what I want to do is I just want to make one modification. So now we have this insertion sort algorithm for an array of ints, But the point that I'm trying to drive home is that you can sort any array that has sortable elements. And that's why we brought up the comparable interface a few lessons ago. Is in the next video, when we talk about our third and final sorting algorithm, which is going to be called selection sort, we're not going to be doing it on int array or string array. We're going to be doing it on an array of person objects to connect back to our discussion of object-oriented programming. And the only way you can sort person objects is by implementing that comparable interface and telling Java, declaring what you want it to mean when one person object is compared against another. And in our characterization, it means that one person object is larger than another if their name is larger than the other person's name. And so we can do something sort of similar like that. We're going to basically baby step into that sort of line of thinking. So now what we're going to do is we're going to have the exact same implementation for the string array, but now you can't say that one string is larger than another string. So you can still reassign these elements, right? And you could still say, okay, I'm going to take I'm going to assign the string at index position j plus 1 to be the string that's currently at index position j. So there's no issue with any of this code. The only issue is in, of course, the data type, right? So we would have to change the key now to a string. The j is still going to be an integer. J is like a counting index. So is I. Those are just index positions. But key is now an element in the array. So now we're talking about a string. And you can't say array of j is larger than key. You would be looking at the length methods called applied to each of these string objects. So now you would just say array of j dot length, right? Now we have to look at something that's comparable, something that's sortable. And then you could say key dot length, and then the rest is the same. So now this just returns a string array. It's going to return the same thing as it received, but it's going to make these swaps in between. And so it's not going to look the same way after the method is run as before the method is run. And now we can go ahead and try that out in our main method. So then this sort and print array is basically what this was doing is it was accepting an int array, right? So basically what we would have to do is we would just have to basically have an overloaded method, right? And then we could go ahead and come up with the formulation for sorting and printing a two-dimensional array of string objects. So we're just going to make that string, right? And then we can still call insertion sort, right? And there's no problem with array of view, but then the only thing we have to do down here is let's figure this out. So now instead of talking about each of the numbers in array of v, we would be talking about each of the strings in array of v. And the same thing, and then maybe instead of calling it number, we could just call it word or something, right? And then you can go ahead and test them. You can go ahead and test them down here. So we can, we're going to try to make this pretty quick here. But what you could do, so now we're going to pass in, and we're going to try sorting the lengths of these strings. So now you're just going to go ahead and make these string arrays instead. So we have 2 minutes left, and we just want to make sure that they are sorted according to their lengths, right? And if two strings have the same length, it doesn't really matter. But you could say something like, you could do something like s, right? And then you could, what if you have an empty string with a length of 0, right? And you can do the same thing here. So then you could have another one. So waterfall, right? And then you could have excellent, and then you could have egg, and then you could have dogs, and then you could have pizza, right? And so these are just string objects of different lengths, and you can make sure that the method is going to work appropriately. So I'm just going to delete these 2 arrays. I know we have 4 arrays when we did bubble sort, but let's just do these 2. So we're going to have a 2-dimensional array, and we said that a 2-dimensional array is a 1-dimensional array of 1-dimensional arrays. So the 2-dimensional array has 2 elements in it. Each of those elements is a 1-dimensional array which has 4 string objects in it. So now what we're going to do is we're going to go ahead and compile, and hopefully we're going to see these arrays aligned by the lengths of the words and increasing by the words in order of increasing length. So now if you run the main method, and indeed that's what you see. So then with array 1, these words get larger and larger, and then same thing happens with array 2. And so egg, dogs, pizza, and then waterfall and excellent, I guess those have the same length, so it doesn't really matter, right? But the whole goal is to do the swap if 2 elements are out of order. So if you have a 5 and a 5, it says, oh, no big deal, right? The Boolean's not true. But if you have a 7 and a 5, then the Boolean's true, and say, okay, these 2 elements I need to switch, okay? But hopefully that kind of helps you understand basically how the insertion sort algorithm works. So we tried it for an example of int arrays and for an example of string arrays. In the next lesson, we're going to talk about one more type of sorting algorithm, and we're going to do it in the context of person objects. So we'll do an int array example and then a string array example, but then we'll go one step further and put it into an object-oriented perspective. So that's all for now. Thanks for watching from UMILS 03. Thanks for watching, and please subscribe.